Okay, so this is a run through of the June 2018 Pearson paper 1F, the non-calculator foundation paper from June 2018. Okay, so the first question talks about writing this number correct to the nearest thousand. Well, we recognise that this is the thousands column, so it could either be 6,000 or it could be 7,000. And halfway is 6,500, so this is nearer to 6,000, so the answer here would be 6,000. Okay, next question talks about this idea of writing these numbers in size order. Remember, there's no harm, guys, in your exams drawing out a number line just to give you a reminder, just a very quick number line, just to remind you how it all works. Up here we're positive, down here we're negative. As we go up we get bigger, and so on. As we go down we get lower, we get smaller. So it says start with the smallest number. Well, -6 would be down here, so we start with the smallest number, -6, and then we've got -5, and we're just working our way up the number line, so 0, 6 and 12. Okay, and then the next part of this question talks about these decimal numbers, and they want them in the size order again, starting with the smallest. Well, quite often when you're doing these questions, it's useful to make them have the same number of decimal places, so we just add on zeros to make them all have 3 decimal places. Then we can literally see that in essence, if we ignore the decimal points, this is like saying 78, this is like saying 780, 708 and so on. So this one's got to be the smallest. It's only worth 78 thousandths, because that would be thousandths. So that's the same as 78 thousandths. This one's the same as 780 thousandths, 870 thousandths and 708 thousandths. So again, we can see that this one with the smallest, I've got 78 on top. This one would be the next one, so that would be 0.708, and then the next one would be 0.78, and the next one would be 0.87. I didn't need that 0 there because the original number was 0.78. Okay, so that's an example of how to write those numbers in smallest order, or size order should I say. The next question talks about writing 20% as a fraction. Well, we should remember that a fraction is a numerator over a denominator. The symbol percent is equivalent to saying out of 100. So that means we'll be writing a fraction over 100. Because it says 20, then it would be 20 over 100. Now, what we should realise is that both for the numerator and the denominator divide by 20. So it would be the same as 1/5. Now this question was only worth 1 mark, so if you wrote it as 20 over 100, they'd accept that as the answer. But you should always think about cancelling fractions down to the smallest terms. Okay, so this next question talks about list of fractions. One of these fractions is not equivalent, so really important. They've highlighted it in bold for you. Not equivalent to a quarter. Okay, so remember, equivalent means that it would be something over 8, so double that we get 2/8, treble that we get 3/12, times that by 4 we get 4/16, times that by 5 we get 5/20, and so on. So basically it's about this idea of recognising equivalence, and we can go backwards of course and cancel down. So we can see that 2/8 is okay. We can see that 4/16 is okay, so it's a choice between these two. And what we can see here is that 3/9, that would be equivalent to 1/3 because it cancels down. So this one must be okay. If we divide that by 15 and divide that by 15, then we get a quarter. So it must be that one. So it says write down the fraction that's not equivalent to a quarter, then it would be 3/9. The question goes on to number 5, and it says write down the first even multiple of 7. So we go down and do the multiples of 7. Multiples means times tables, so you times up, so 7, 14, 21. It wants the first even multiple. Well, there's your first even multiple, so the answer is 14. So on the answer line, 14. These questions ask you to simplify, so we're having to simplify 3 lots of 4t. Well, that's going to be 12t. And we're having to simplify this, well, because they're all like terms, they're all to do with just the power of a of 1. So we've got 8a's take away 3a's, which is 5a's. We've still got to add the 2a's, so altogether we end up with 7a's. Okay, so this next question talks about a probability scale going from 0 to 1, and what we've got to remember about probability scales is a probability of 0 means things are impossible to happen, there's no chance of them happening, and a probability of 1 means that there's 100%, they are certain to happen, and in the middle, equally likely, or even. So that's how a probability scale should be interpreted. Now we've got to, so it says write down the letter of the event that is certain. Well, this means certain, so that'll be the letter D. Write down the letter of an event that is unlikely. Well, this area here is unlikely, but it says unlikely, not impossible, so it would be B. And then the question goes on and talks about there are 12 counters in a bag. Caitlin takes a random counter out of the bag, so that means every probability will be out of 12 because all 12 counters are in play. Show that the probability, so it's show that, so that means we've got to show some numbers, some calculations, and probability that this counter is yellow or green. Okay, so that means we need to know how many yellows and how many greens there were. So yellows is 2 out of 12. It says the rest of the counters are green, so we've got 3, 4, 6, so that means green counters must be 6 out of 12. 6, 12 take away 6. So we know that these two probabilities are okay, so we've got 2 twelfths plus 6 twelfths. When we see this word or in probability questions, then we should be thinking of it's that one or that one, so we add them together to get the total number. And here we've got 8 twelfths, and that's equivalent to 2/3. So that's what show that means. It basically wants you to go through showing where you get your numbers from, and then cancel it down to show that the answer is going to be 2/3 at the end of it. Okay, so this question talks about 3 kilograms of meat costing £54. So this is asking us to do a calculation. So 3 into 54. It's a non-calculator paper because we need to know the cost of 1 kilogram. So 3 into 5 is 1, remainder 2, and 3 into 24 is 8. So this is telling us that it costs £18 per kilogram. The question then goes on and says she wants to buy 2 kilograms. Well, that's going to be 2 lots of 18, so £36. So that would be the answer for that question. This next question talks about parts of a circle. So you need to remember all your parts of a circle. So this is the centre, because they're telling you it's the centre. So when you go from the centre to the outside, it's known as the radius. If you had a line that went from one part of the circumference to the other, then it's known as a chord. If you had a part of the circle shaded in from trapped between 2 radii, then that's known as a sector. And if you had a chord, it traps between the chord and the circumference, it traps the segment. And if you go all the way around the circle, so all the way around is known as the circumference. And if you go from one side to the other through the centre of the circle, then it's known as the diameter. And this last part of the question talks about this straight line touching the circle at one point. Well, technically that's touched the radius from the centre at one point. It makes 90 degrees and it's called a tangent. So the tangent to the circle. So you need to get to grips with the names of all the special parts of the circle, guys. Okay, this next question talks about somebody going on holiday. So there's 4 of them goes on holiday. And they'll share the costs. So in other words, we're going to be doing 4s into something. And here are the costs, so it tells us that and that. Work out how much Tim pays. Okay, so we've got to do this 4 into the total of these. So this question is asking us to add those together. So if we line up all our place values, so we're going to add up those to get the total cost of the holiday. So 8, 12, 14, 2, 8, 10, 11, and 1 plus 1 is 2. So the total cost of the holiday was £2,140, and because we want to work out Tim's share, then we have to do 4s into that. So 4s into 2, 0. All the remainders always carry through here, so the remainder here was 2. And then we're saying how many 4s going to 21? Well, if we go in our 4 times table, we know that 5 4s are 20. Take that away from 21, leaves a remainder of 1. How many 4s going to 14? Well, 3 4s are 12. Take away 12 from 14 is 2. How many 4s go to 20? Well, 5. So the answer is £535. So £535. So that's how much Tim pays. Write down an example to show each of the following 2 statements is not correct. Okay, so it says the factors of an even number are always even, so we're trying to show that it's not always correct. So factors go into, so basically we've got to think of even numbers. So if we take the number 12 for example, then the factors of 12 are 1, 3, 4, 6, 12, and 2. So it's saying write down an example to show that each of the following 2 statements is not correct. The factors of an even number are always even. Well, we can see here from 12 for example that there is 1, 3, they're both odd. So this would be enough to show the answer. So here we'd put 12 as the answer. Okay, 12 has an odd factor 1. Okay, so all the digits in odd numbers are odd. So all the digits in odd numbers are odd. So digits are what makes up numbers, and odd numbers are odd. Okay, so if we take an odd number 43, then it has the digits are 4, 3. 4 is even. Okay, so that shows that the statement's not true. Okay, could add lots, could add 23, so anything that starts with an even number, 27, 47, 69, anything like that. Those are odds with an even digit. Okay, so this question talks about a shop selling particular items. It's drawn a composite bar chart, which basically means you've put all the components on top of each other. So this bar here, for example, this little bit here is showing desktop computers were 100. Laptops, well, it went from 100 up to, well, you've got to be careful with scale. So we can see that each of these squares is worth 20. So 1 square equals 20. Because we count up 100, 120, 140, 160, 180, 200. So we can see here that the laptops was 20, 40, 60, 80, 100, 20, 40, 60. So the laptops were 160. That was 100. And then we can see this went 20, 40, 60. So from there to there was 60. So that's how composite bar charts can be interpreted. So now we can look at the question. It says write down the number of desktop computers sold in 2015. Well, 2015 desktop computers are represented by this black, and so that was 100. Write out the total, work out the total number of laptops sold in the 3 years. Well, the laptops are represented by the shade, the diagonal shading. So we know there's 160 there. So we know the scale's 20, so 20, 40, 60, 80, 180, 200, 220. So that was 220. And then we've got 40, 140, 240, 260, 280. So 280. So we need to do 160, 220, 280, add those together, so 200, 400, 500, 580, 600, 660. So do a check. 0, 8 and 10, 16, 1 over, 2, 4, 6, 660. Okay, so 660. There is a third part to this question. State the item that had the greatest increase in sales. Okay, so the greatest increase in sales. Well, we can see here that that was a small amount. So it started from 60, and then the bar went even wider, and the bar went even wider still. So it's going to be tablets. Tablets in 2015, 60 sales. And in 2017 we can see that it was 100, 200, 280, 300, 320, 340, 340 sales, 5 times plus increase. Okay, so as long as we've shown that there's a reason that they started at 60, they went up to 340, it's a 5 times increase, so larger increase than desktop and laptops. Okay, so that should be enough to give you the marks. If you want to be really clever, then you could work out the increase from the desktops. So the desktops went from 100 to 160, so that was only an increase of 60 up. And for the laptops, they started at 160 and they went to 280, which was an increase of 120. Well, we can see that 340 from 60 was a much bigger increase. So lots of ways of thinking about that question. Question goes on. It says in 2017 more tablets were sold than... This means the shop makes more profit from the sales of tablets. Is he correct? It's a 1 mark question, so they're only asking for a simple answer, and the answer will be no. It depends on the actual price of the tablets and desktop computers, because profit will depend on price and cost of buying. So basically compared to bought price. Yeah, so basically it's about the fact you've got to recognise that it depends on how much they actually sell the computers for and what profit they make. Okay, so next question then. It talks about a piece of wire 240 centimetres long, cuts 2, right, okay, so that's telling us 90 centimetres cut. So 240 minus 90 is 150 centimetres left. So again, notice what I'm doing here, guys. As I'm seeing a sentence with a calculation I can do, I'm doing it by the sentence, so it kind of reminds me where I'm at. He then cuts the rest of the wire into as many 40 centimetres lengths as possible. So basically we've got 150 centimetres and we're cutting it into 40 centimetres lengths. So 40, 80, 120, only 30 left. So therefore he can get 3 cuts. So 3 cuts. Okay, so that's how that question could be done. This question talks about the same monthly salary. So each month Kevin saves 28% of his salary and spends the rest. So 72% spent. Harry spends 3/4 of his salary and saves the rest. So he's saving 1/4. Saved. And the amount of salary Isabel saves, the amount of salary she spends is. Work out who saves the most. Okay, so saves the most. Well, might be here easier to work in percentages, so we need the highest percent. Okay, so it talks here about saves. So when you do ratios, give them headings. So saves, spend. So 28% saved for Gavin. Spends 3/4, saves the rest. So he saves a quarter, which is equivalent to 25%. And here we can see that there's a ratio 3 to 7, which means saved 3/10, spent 7/10. 3 plus 7 is 10, so that's how we can turn them into fractions. And this fraction then will become a percentage, so 3/10 is 30%. If you're not sure why, then think about how equivalent fractions work. Out of 100, so you times that by 10, so you times that by 10, and you end up with 30%. So we can see from the way the question's been worded that we want to know who saves the most. We've shown all our workings around the question itself, and we can see that Isabel saved 30%. So Isabel saved the most with 30% being the highest. Okay, so that's how that question could have been done. Alright, so here we've got some substitutions to do, some expansions and solving, so a little bit of algebra. You know you're going to get some, guys, so it's worth practicing. So substitutions, my recommendation is that when you substitute, replace the letter with a bracket and then put the number inside. Then you can do the calculation, so 4 lots of 5 is 20, plus 3 lots of -2 is -6. And then what we've got to remember is that when we're adding a negative, we get smaller. So in other words, we end up doing 20 take away 6, which is 14. So add a negative, you get smaller. If you take away a positive, you also get smaller. So literally, we add a negative, it's the same as take away. And if we take away a positive, it's the same as take away. And if we take away a negative, then it's same as adding. You get bigger. So you need to practice the rules of directed numbers if you don't already know them, guys. Okay, so this one says expand. So expand means multiply out. That's one interpretation of expanding. So this is saying you're doing 4 e's times an e. Well, anything times itself is squaring, so this gives you 4e squared, and then you're doing 4 e's times 2. Well, 4 times 2 is 8, you still got an e, so it's 8e, so the answer will be 4e squared plus 8e. This one says solve, so that means we've got to find the value of m that makes this true. Lots of ways of thinking about this. 3 times something gives you 21. So the something must be 7, so that means m take away 4 would be 7, so m equals 11. That's one way of doing it. Another way of doing it is to expand the bracket, so you end up with 3m's take away 12 equals 21, and then you solve this by moving terms to other sides to leave the m on its own as the subject. So we add 12 to both sides, so we end up with 3m's is worth 33. Now remember why we've added 12, because -12 plus 12 becomes 0. So we must do that to balance it, and then we divide by 3 because we want to know the value of just one m. So m is going to be 11. So there are lots of ways of trying to do these kind of problems. Either way doesn't matter, as long as you get the correct answer of 11. Okay, so that's how those questions could be done. Okay, so we've got a question here that talks about some chocolates in a box. So it says 1/4 of the chocolates contains nuts, so 3/4 no nuts. Remember, good idea as you see the questions appear, as you see calculations you can do, write them next to the sentences and then you can see what's going on. So the rest of the chocolates do not contain nuts. Okay, so we've already worked that out, 3/4. It wants you to write down the ratio of the number of chocolates that contain nuts to the ones that don't contain nuts. So we've got nuts to no nuts, and we've seen there's 1/4 containing nuts and there's 3/4 not containing nuts, and it wants the answer in the form of 1 to n. So in other words, we need a 1 there, and this is going to be our n. Well, one of the strategies that you use with ratios is look for equivalent ratios, and when we can turn a quarter into 1 by timesing by 4, then we can see that we can do the same here, times that by 4, so that will give us 3. 3 over 4 times 4 over 1 is 12 over 4, which cancels to 3. Okay, remember 4 can be written as a fraction, so 4 over 1, any whole number can be over 1 as a fraction, and then when you multiply across and then cancel the fraction down, and we can see that it's 3, so the answer on the answer line will be 1 to 3. Remember, ratios must have the 2 dots between each different variable. Okay, so that's how that question can be done. Alright, so here we're saying that A is the set of, so basically we use these curly brackets to define a set, so the set of numbers. And it's saying it's multiples of 5, so the 5 times table between 14 and 26, so that means we're looking at the numbers 14 and 26, so it's going to be 15, 20 and 25. And then it's saying for set B, it's the odd numbers between 14 and 26. So the odd numbers between there will be 15, 17, 19, 21, 23, 25. It wants you to list the members of A union B. Okay, so if you're not familiar with this symbol, it stands for the word union, and that means basically or. So this is saying what is in A or B. So in other words, we need to be writing out everything that's in this list. So we had 15, 17, 19, 20, 21, 23, 25. Okay, so we had 15. Don't write them both twice because you don't need to write it once because it's what's in the union. So 15, 17, 19, 20 was there, 21, 23 and 25 again. So that's what that means. The union is what's in both, so A or B. So what is in both? That's another interpretation of the union. Okay, so this one says describe the members in A intersection B. So this is a special symbol we use for the intersection. So if you had a Venn diagram, then that would be A intersection B, if that circle represented B and that represented A. And basically the intersection is what it basically means what is in A and B. So it has to be in both. And when we look at these lists, we can see 15's in both and we can see 25's in both. So for this answer it would be just 15 and 25. Those are the only two that's in both. Okay, so set language and the union, and it's linked to Venn diagrams, because if we looked at the Venn diagram for A union B, then if that was A and B, A union B would be what's in both circles, including the intersection. Okay. Here we've got some classic fraction work. Again, lots of ways of doing this. We could do 2 plus 1, do the whole parts separate, and then do a seventh plus a quarter, and then we recognise that's equivalent to something out of 28 because we need a lowest common denominator to do things. So what 7 goes into and what 4 goes into, and we can see that to get 7 to become that we had to times by 4, and to get that to become that we had to times by 7. So here we times that by 4, so that means times that by 4 and times that by 4, and here we have to times this by 7, so 7 times 1 and 7 times 4. We're adding, we're talking about 28ths, so it'll be 11 28ths. So that would be the final answer for that one. No, it wouldn't, because it says work out the total of that. So the total of this would be this plus this. So the final answer will be 3 and 11 28ths. Again, it's important to go back and check the question, what the question wanted. So we can see that would be the answer to that question. Another way of doing it is you could turn this into an improper fraction, top heavy some people call it. So 7 2s are 14 plus 1 is 15. So in other words, we just worked out how many sevenths in all of that. In each whole seventh there's 7 of them. 2 whole ones would be 14 sevenths plus the extra 1. And then we're adding 4, 1, 5, so 5 quarters. And again we'd make that 28ths. So 28ths, so we times this one by 4, times this one by 7. and so 560 and 5 7s are 35, we're adding, so that gives me 95 28ths, and we can see that 3 times 28 is 60 84, so we know that we've got 3 whole ones, and if we do 95 take away 84 we get 11, so we're left with 11 28ths. Again, same answer, can't be any different, just a different way of doing it. So that's a couple of ways that you could have done those. If you know your decimals well, then you could have turned them both into decimals and added those as well. You know, there's lots of ways of doing them, but these are 2 classic methods. This question says we've got to do a division with fractions. Now when you're dividing with fractions, the best way to do it is to turn them into both fractions. So basically with this, turn both parts into fractions. Now one of them's already a fraction, so that's fine, but this one is asking how many fifths, so it'll be 6 fifths divided by 3/4. Now you've got lots of ways of thinking about this. Some of you learn a thing called keep, flip, change, called KFC. That's one way of thinking about it. So basically it means keep the first fraction, flip the second fraction, change the division into a multiplication. Really what you're doing is you're turning it into a multiplication by multiplying by the reciprocal of 3/4, and the reciprocal of 3/4 is 4/3. And then when you multiply fractions, you multiply the numerators, 24, multiply the denominators, 15, and the question did say writing it in its simplest form, so in other words we've got to turn it back into a mixed number. So how many 15s in 24 is 1, leaving 9, so 24 take away 15 equals 9, so we've got 9 15ths, but then we recognise that 9 and 15 both divide by 3, so that's equivalent to 1 and 3 fifths, so the final answer would be 1 and 3 fifths. Okay, so we've got a ratio problem here. So we ask ourselves what kind of strategy we're going to use, and what we can see here is it talks about houses and flats. So we've got houses to flats is 7:4. This next sentence talks about flats to bungalows in the ratio of 8:5. Well, when we see 2 different ratios connected by a common denominator, a common link, both talking with flats, then basically what we do is we link all of them together in a single ratio, so H to F to B, and we write in the information we knew. So we had that one as 7:4, and we had this one as 8:5, and basically we want to rewrite this as a single ratio, which means we need a lowest common multiple. So therefore we're going to work with 8, because 4 multiple is 8, 4 times 2 is 8, and 8 times 1 is that. So this one stays the same, still got a ratio of 8:5, but this ratio we need an equivalent one, because we want to be working with 8 flats. So we had to double this one to make the 8 flats, so this will become 14. So we can now see that the combined ratios would be, for every 14 houses there'd be 8 flats and 5 bungalows. That's how they're all connected together. It tells us in the question there are 50 bungalows, so we can put the 50 there, and it wants to know how many houses there are. So to turn 5 into 50 we multiply by 10, so because it's about equivalent ratios now, then we multiply that by 10 and we get an answer of 14 times 10 equals 140 houses. So in these ratio questions where they give you 2 sets of information and there's a link between the 2 sets, in this case it was about the flat link, then writing them as a single ratio with all 3 variables, look for a lowest common multiple to look for a connection, and then turn them into equivalents. That's usually a good strategy with those kind of questions. Okay, so we've got a scenario here with lots of information. So Rennie buys 5 kilograms of sweets herself, she pays £10. Okay, so there's a calculation we can do here then. So we can do 10 divided by 5, so she paid £2 per kilogram. So that's how much she paid for each kilogram. She puts all the sweets into bags. She puts 250 grams of sweets into each bag. Okay, so 1 kilogram is equal to 1,000 grams. So 1 kilogram is equivalent to 4 bags. So cost is £2 divided by 4. So that's 50p per bag. So it costs 50p per bag. Alright, she sells each bag for 65p. So the profit per bag is 65 minus 50, so 15p. So she makes 15p per bag. She sells all the bags of sweets. Work out the percentage profit. Okay, so we know from this bit here that each kilogram was 4 bags. So we know that 5 kilograms is equivalent to 20 bags. And we know that she made a profit of 15p per bag. So total profit is 20 times 15p, which is going to be 300 pence, which is £3. And it says work out her percentage profit. Now when you see on a dot line a percent symbol, it technically is asking you to find a fraction and times it by 100. That's what those kind of questions tend to always come down to. So we've got to think what this fraction is about. Well, it's about the profit over the original cost. So the profit made over the original cost times 100. Alright, so we saw that the profit made was £3. The original cost was £10, and we're timesing by 100. So literally what we've got here is we've got 3/10 times 100. So we've got 300, because 100 is like 100 over 1. So we've got 300 over 10, which is 30%. Okay, so that's one way to do it. There are other ways. You could have worked out the total cost, the total sales. So you could have done 20 times 65. So we could have done 20 times 65, which would have been 1,300. The cost of it was 1,000, and then we could see that this would cancel by dividing by 100, divide by 100. So we end up with 13/10, which is equivalent to 130%. The original is 100%, so 30% profit. So that's one alternative method. There are other ways, but I suspect the easiest way is to go through step by step. As you see some information that allows you to do a calculation, do it, build up the information, and then away you go. Okay, so we've got a question here. Got some awkward numbers in. It's a non-calculator paper, so hopefully somewhere they're going to say the word estimate, and we can see fairly quickly it is about estimating. So estimating means round the numbers to make them easier to work with, and the best way of doing this is round all numbers to one significant figure. And I will put a proviso, unless you can see an easy multiple connection. Now what we mean by an easy multiple connection is if we've got something like 3.47 divided by 0.247, something like that, then we can see actually that instead of rounding this to one significant figure as 0.2, it would be easier to make it 0.3, because this would go to 3. And then we can see that we've got a nice easy calculation to do, 3 divided by 3 and so on. So sometimes you can see an easy connection for multiples and you're estimating, so all you want is a quick feel for the answer. The one significant figure though tends to be what the exam board are anticipating that most students will do, and there's not a problem with that. It's estimating, you just want to feel for it. So this to one significant figure will be 3,000. This to one significant figure would be 20. And this still wants to give a figure. Well, it's already wants to give a figure. It's 8. Okay, so let's have a look. He knows an average speed. So this question's mentioned speed. So we should be thinking of speed is equal to, because it's average, then it's the total distance. So we should be thinking of total distance divided by total time. So that's the formula for average speed. So average speed equals total distance divided by total time. So it's asking us to estimate how many days he'll take to complete the race. Okay, so in other words, we need to know the total time taken. Alright, so total time will be equal to the total distance, 3,000, divided by the total, so the average speed. Now here's one of those connection things. Now we could use the 20, but if we notice 15.12 is actually a nice factor of 30. So we could have used 15 or 20. Either of those would have given us an estimate. I'm going to use 15 because it's closer to 15.12, and then I can see that we've got 30 divided by 15, which is 2. Let's use those two, and then we've got hundreds left, so it'll be 200. So this is 200 hours, and the question wanted to know how many days. So it's saying he races 8 hours per day, so he's doing 8 hours per day. So we're going to do 200 divided by 8. Now you either remember that you can do 8s into 200, or you remember the quick way of doing 8s into 200. You halve, halve and halve again. So you get 25 days. If you'd have done it the other way, then you would have ended up with 3,000 divided by 20. Again, divide by 10, and then halve 300. That would have been 150. You would have divided that by 8, but you're estimating, so you would have made the 150 160, a nice multiple of 8, and that would have given you 20 days. So there's a couple of alternatives of how to do that question. It then goes on and says that he trains for the race, his average speed increases. How does this affect your answer? Well, if his speed increases, it means he's taking less time. So speed increase, so needs less time. So we'll take less days. Okay, so that's how that question could have been attempted. Okay, so we've got here a question that's asking us to look at a square-based pyramid, and it wants us to draw an accurate front elevation. Okay, so we've got to remember they've given us a clue that the front elevation would be there. They could have asked us to do the side elevation, and they could have asked us to do the plan view. So when you're doing views, then those are the three views that they can ask you to work with. So the plan view of this would have been a square, because you're looking down from the top as a bird, and you'd have had the dot, and then you would have seen the edges of the triangles that make up, and that would have been the plan view. The side elevation, well, as it happens because it's a square base pyramid, it would actually be the same as the front elevation. So when we look at this from the front, we can see that what we would see is we would see the bottom here. We would then see a triangle where the two lengths here are the same length, but the height of that triangle would be the distance from the bottom here to the vertex. So we know that that is going to be 4 centimeters. We know that this is going to be 6 centimeters, and they're telling us in the question that the side length here from the vertex to the center of the shape is 5 centimeters. So basically it wants us to draw this shape accurately. So it says draw an accurate front elevation, and these were centimetre squares, so literally they expect you to draw, I'll do it from the top there, 4 centimetres, so 1, 2, 1, 2, 3, 4. 3 centimetres that way. You do this with a ruler, guys, but I'm just doing it quickly to demonstrate. And then you would join that up, and you should find that that is 5 centimetres, and that is 5 centimetres exactly, and that would be 4 centimetres, and that's what you would see, just that isosceles triangle where that was 5 centimetres, 6 centimetres, 5 centimetres, and the distance from there to there would have been 4 centimetres. Okay, so nets and plan views, worth practicing, fairly straightforward topic once you understand how to look at pictures. It says work out the total surface area of the pyramid. So basically when we want the surface area we need the net. So surface area, need net of shape. Then work out area of all faces to add together. Okay, so this question wanted you to carry on and do the surface area. So the net of this then, and when we fold this down to get the net, it would be a square with 4 triangles. And they're telling us, by the way this question has been worded, that this is 5 centimetres, so we know from there to there is 5, and we know from there to the centre is 3, and that's going to be a right angle, and we know that is 6 centimetres. Now we know that's 3 because they told us that this point here is the midpoint, it's the middle of that line. All these triangles are congruent. So basically we work out the area of one triangle where that's 3, that's 4, 5, sorry, that's 5, and that's 3. So we recognise the area of a triangle is a half times the base times the height. So in this case it's going to be a half times the base length of 6 times the height they gave us, which was 5, 30, 15. And the square was 6 by 6, so we know the area of that is length times width, so that's 6 times 6, which equals 36 square centimetres. And because we want the total surface area, then we've got, so the total surface area is equal to 4 times 15 for the 4 triangles, plus the 36. Well, when you work all that out, 4 15s are 60 plus 36, so 96 square centimetres. Remember, it's important to put the units down. This question, they gave you no units on the answer line. Watch out for that, because they're expecting you to put the units, okay, because that gets you a mark for the units. So watch for units. Okay, so that's how that question could be done. Okay, so the question goes on and it talks about a shape on a coordinate grid, and they're telling us that they're all squares. So that means that that distance is equal to that distance is equal to that distance is equal to that distance. So in other words, going across here, we started at 6 on the x-axis and we went to 38 on the x-axis. So across from there to there, we went a total distance of 32. 32 divided by 4 is 8. So that means this one here must be at 14. This one here must be at 22. This one here must be at 28, and so on. So that's the horizontal. And because we know it's a square, then each of these have gone up 8. So we know this goes from 6 to 14 to 22 to 28 to 36. So we've worked out the coordinates of the diagram, and it says point A has coordinates, point C, work out the coordinates of C. Okay, so we can see that the x coordinate of C will be 22, because we went across from 6 adding 8, 6 to 14 to 22. And we can see that the way the diagram's been drawn, okay, okay, interesting. I haven't quite been clear enough about whether C is exactly in the middle or whether it should be there, because they join that, and I think it's a symmetrical pattern. So I'm going to take a punt that C is going to be well, if that was 8, then each section is going to be 2, 4, 6. So I'm going to say that is 6 from there to there. And therefore it's going to be 14 plus 6, so 20. Okay, apologies if I'm wrong, but that seems to be the way the pattern's been drawn. It's been drawn symmetrical, and they've made this a point of reference being 3/4 of the way up there. Okay, so that's how that question could be done. Okay, so this question talks about on the grid, draw the graph of. Well, if you've got to draw, then you need coordinates. So basically we know that we're going to have a little table of coordinates, and we choose some simple numbers. Because it's a straight line, we recognise this is a linear graph because it's got power 1 for the x, and basically we're going to choose some very simple numbers. We only need 3 of them, so we're going to choose 0, 1 and 2. Now to get the y value, so to get y, you multiply x by 4 and subtract that from 1. That's basically what that rule is saying. It's saying multiply the x by 4 and then subtract it from 1. So y is going to equal 1 take away 4 lots of 0. Well, 4 lots of 0 is 0, so that's going to be 1. Then y is going to be 1 take away 4 lots of 1. Well, that's 1 take away 4, which is -3. And then to use this value, you're going to end up with the y is equal to 1 take away 4 lots of 2. All I'm doing is I'm replacing the x with the value we've chosen, and that's 1 take away 8, which is -7. Now if this has worked, this is known as the gradient. So the number in front of the x is known as the gradient, how steep the line is. And basically that means for every one you go across x, you go up or down the gradient. Now because it's a negative, you're going down, so it's a negative gradient. So we can check by saying we went to 1 cross, it should go down by 4, and 1 take away 4 is -3. We went across 1 on the x, so it should go down by 4. And when you go from -3 to -7, you go down by 4. So we know those coordinates should work. So on the grid we plot those coordinates. So the first coordinate is 0, 1. The next coordinate is 1, -3. Now remember, we're getting these coordinates by just reading the x number and the y number. All coordinates are x first, y second, across the axes up or down. And then the next one was 1, -3, and the next one was 2, -7. So 2, -7. Now if we've got that correct, then of course when we get our ruler we should find that the 3 dots, or 3 crosses in this case, line up, which they do. And then we draw across the whole graph, because the question wanted the graph to go from -3 to +3, so we make sure we go across the whole graph. Okay, so that's how that question could have been done. Okay. Alright, so drawing a graph, need coordinates, plot the coordinates, draw the graph. Okay, so last question for this paper, and it talks about column vectors. And a column vector, so the column vector 5, 2 just means that somewhere in space we started at a point and we went across 5 and we went up 2. So representing that vector would be that line with an arrow going in the direction that we moved. So we went across 5 up 2. That's what that vector would be, and then we'd put the A there. So if we had to draw them, that's how that would work. This one's saying we've got to do the calculations though. So in other words, we've got 2 lots of 5, 2, and we're adding on 1 lot of the B. So basically we double this one, so that's 10, 4, and we're adding on -1, 7. Well, the way vectors work is you just literally come across adding up. So we've got 10 plus -1, which is 9, and we've got 4 plus 7, which is 11. So the answer would be that. So column vectors are written like that. So on the answer line, you'd be writing 9, 11. Okay, so that's how column vectors work, and if you was asked to sketch them, then you could do that. So if we had to sketch the vector 2a plus 2b, then we'd have a start, and this is telling us we go 9 across, we go 11 up, and then that would be a vector. The direction of travel was in that direction, so we put the arrow on, and this would be 2a plus b. Okay, so that's paper 1, non-calculated paper from 2018, Pearson, hopefully of use to you guys.